In this question, we're given 4 different representations of linear relations, 2 of which are ordered pairs, and 2 of which are graphs. And we're asked to determine how many of them have a rate of change of 5. So for ordered pairs, we can figure out the rate of change by looking at the change in C divided by the change in N, where C is the dependent variable and N is the independent variable. So let's look at our first ordered pair table, and we can look at the change in C here between any of the 2 points and the change in N as well. So if we pick the first 2, we can see the change in C here would be 90 minus 50 or 40. And the change in N here would be 8 minus 0. So 8 goes in there once, 8 goes in there 5 times, so we end up with a rate of change of 5. So that looks like it works, but let's double check just to make sure we didn't make a mistake. Let's try another couple of points in this ordered pair table. Let's look at these 2 points. So the change in C would be 130 minus 90, which would be 40. And the change in N would be 16 minus 8, which would be 8 as well. And again, we can see that 8 goes in there once, 5 times, so our rate of change is 5. So we're pretty confident that that first ordered pair table does represent a linear relationship with a rate of change of 5. Okay, let's try the next ordered pair table. So here we'll look at the rate change in C here, and this would be 35 minus 30 or 5. And for the change in N, we'd get 12 minus 10 or 2, which would give us a rate of change of 2.5. which is not what we're looking for. We're looking for a rate of change of 5. Let's do a quick double check. We'll just try another couple of points here just to make sure we didn't make a mistake. So we'll try these 2. The rate of change there would be 5, 40 minus 35, and the rate of change in N would be 2. Again, 14 minus 12, which is 2, and again it gives us a rate of change of 2.5, which is not correct. So we can say that this ordered pair table does not represent a rate of change of 5. Now let's look at our graphs. And for graphs, we can represent the rate of change as the rise over the run. So we can remove this here and say that our rate of change is rise over run. So our first graph here, let's just draw in a run here and a rise. So we're going between this point here and this point here. It doesn't matter which points you pick. And we can see that each one of the points on the vertical or C axis is 5 units. So 5, 10, 15, 20. So our rise here is from here, which is 5, 10, 15 units. And our run would be from here to here. And for the horizontal axis, each unit here is 1 step along the way. So our run would be 1, 2, 3, 4, 5, 6 units. So we stick that in there. And we can divide by 3 here. So 3 goes in there twice, 3 goes in there 5 times. And again, our rate of change here is 2.5, which is not 5. Therefore, this graph does not represent a rate of change of 5. Alright, so let's look at our last option here. Put back the run there. So if we look at the rise here, we can see that this is a horizontal line, so there is no up or down, so therefore the rise is 0. Here we go, rise of 0. And then of course it doesn't matter what the run is here. So let's just say for argument's sake we're going from this point here to this point here, and that would represent a run of 6 units. So we'll stick that in the bottom here, 6 units. So the rise over the run would still be 0. And that is not a rate of change of 5, so therefore this graph does not represent a rate of change of 5. So now we have enough information to answer our question. How many of the linear relationships have a rate of change of 5? Well, only one of them does. And so there you go. The answer is D.